and then combine the cognitive matching score with the face mark matching score. Then they get matched at rank 1. And the same thing for the two images of the woman who were, they were arrested at 2 different times, and so facial appearance is slightly different, and the cognitive doesn't find it at rank 1. So FaceWax is the name of the software from Cognitive. And this is a project it's the most recent project and started just a few months ago, because again, in order to work on it, you need a database. And we looked at the previous 2 or 3 studies which have been done, and they sort of fake the data in the following way. In one of the study, they had a few hundred subjects, they had their images, and then the sketch artist, not a police sketch artist, but a professional sketch artist, drew a sketch by looking at the face images, okay? And then they did the matching, okay? In the second case, the people simply blurred the images or distorted the original image and then tried to match it. But we wanted to work with the real database. So anyway, we haven't made too much progress on it, but I'm just showing you what we are trying to do and by this illustration. So again, as I said, this is a real database. So the sketch which you see there is a forensic artist sketch. And what you see in the image there, mugshot, is the actual mugshot of that person. And if I just do the Cognitech and match the sketch with the mugshot, the matching score is 0.01, which is very low, as you would expect, because the 2 representations are completely different. One is a line drawing, the other is a grayscale image. So what we are trying to do is to take that sketch, okay, and then do fit a morphable model to it, do the texture mapping, and now you can generate, once you have a 3D model, then you can generate multiple viewpoints of that face. But most mugshots are frontal, so that's just to illustrate that the model is capable of generating images at different viewpoints. And now if we do the matching, the score is 0.16. So there is a definite improvement. And as I said, this is the work in progress, and we don't have too many sketch to photo pairs yet. I mean, getting the data is not always easy, so we are lucky to at least get this much data. But we have about 20 sketch and photo pairs, and these are some of the things I'm showing you, and how the sketch has been converted into a photo. So this will be the PhD thesis of the new PhD student who just started in the fall semester. So anyway, this is just preliminary result. Finally, the last thing I want to tell you, some of you may have been to Angkor Wat. So if you haven't been, you should go. It's not too far away from Bangkok. Only 1 hour flight, 50-minute flight from here. So it's a beautiful temple. So I don't know, all of a sudden we get a call from some amateur, semi-professional archaeologist who first contacted Cognitech about doing some face recognition work, and they said, well, we don't do this sort of thing. Contact Anil Jain, so they contacted me. So basically, they are these portraits of women in Angkor Wat, and somebody has actually captured these images, high-resolution digital images, in about 1700. But there's not been much study done on what are the ethnic characteristics of these women. And what this guy Ken Davis wanted to do was to see if we can do some analysis of this. And of course, first thing we did was extract some facial marks, and then try to measure the similarity between 2 different faces based on the not facial marks, I mean the facial features, and pick the AM model and extract the facial feature points, find the similarity between 2 faces, and then do a grouping, basically unsupervised clustering of the data. So this is just showing some facial marks, and the animation is showing how to align two different face images in order to compute the similarity. And once you have the similarity, you can do a grouping using what is called data clustering. And once you have grouping, you get some groups, and now it is up to the archaeologist to say whether these groups make sense or not. And so, as I said, this is the work which we are doing. So here is the similarity matrix for 10 faces. You have a 10 by 10 similarity matrix. Another thing we can do is we can convert the similarity matrix into a metric space, and this is called multidimensional scaling. And this is often a well-known technique because you want to know some actual attributes which result in this similarity. And so we can also do the clustering in this multidimensional space, and you get different clustering results. So one may be more meaningful than the other. And so this, as I said, this is again work in progress. So to summarize, face recognition is a very difficult pattern recognition problem, and it is of interest not only from the as an academic challenge, because humans have the ability to recognize each other. We would like to have computers with the same capability, but it also has a large number of applications. So for simple applications, the system works okay. I mean, for access control, if you want to access your lab or office door, it works fine. But for more difficult scenarios, even mobile phone application, you want to authenticate yourself or point the mobile phone towards some person and search the database. I mean, that's a difficult problem. And so there's a lot of work that needs to be done. And I think the use of 3D models and 3D sensing certainly has improved the performance, particularly the 3D model. 3D imaging is still not yet affordable, and it's not something which will be around in the near future. And there are a large number of forensic applications as well as civilian applications. So with that, I'll stop, and if there are any questions, I'll be happy to answer. Thank you. Yes? No, because finding the confidence is not that easy. I mean, so I don't think any attempt is done, because that means somehow there should be some measure to determine the local fit. Yes, yes. I think you can do some of that. Yes. Yes.
Do you have any work that's been done on inferring
skull shape using photo?
Yes, because that would be more invariant than people should be.
Right. So, I mean, what you're referring to is what are referred to as anthropometric measurements, and usually anthropologists work on it, but they generally work with the skulls which are found, actual bones to I think using 2D images to do those kinds of measurements is not very useful. Now, surgeons who do facial surgery or reconstruction, or even some orthodontist or whatever the proper name for that specialty is, they are using 3D facial sensing to do some measurements for that purpose.
Well, I'm talking about inferring the bone structure from the
2D image.
from the 2D image.
I think that's very difficult. Yeah, I don't know of anybody who is successful or even trying to do that. is